So we can convert any normal distributed data set into a standardized distribution with a z-score using that formula I showed earlier, using this formula right here. All we need is to know what the average is and to know what the standard deviation is, and you can standardize any distribution you want, any normal distribution you want. Okay, so here it's saying if the z-score is less than or equal to 1.5, how much area is there? So here, drawing the picture always helps me. Okay, the middle of a standard scale is 0. Here I'm saying 1.5 standard deviation. So how much is this area? Okay, less than or equal to. Two things that we should be aware of. First is something called the z-table. This is sort of an archaic method, but this is the z-table. If I'm looking up 1.5 standard deviation, it's going to be in this row. Okay, so somewhere in this row, 1.5, and here in this case I want 1.5.0. So where 0.0 adds up to 1.5, so 0.00 plus 1.5 is 1.50. Then that area is 93%. Okay, so I've tried to draw it here where 1.5 meets up with 0.00 is about 93%. In minitab, you don't need these tables. Minitab does a better job. It doesn't do so much rounding. Probability distribution, normal distribution. Okay, here when the mean is 0 and the spread is 1, also known as the standard distribution or z-scores, the cumulative area of 1.5 standard deviations. Sorry, I've got input column there. Let's change it to input constant. 1.5 standard deviations. Again, is 9.933 with more digits. So as you can see, you can get both of these. If I want what is the area between positive 1 standard deviation and 2 standard deviations, so that is the area in between 1 standard deviation and 2 standard deviations. I know that it is on the right side of half because these are positive values. Okay, so I'm looking for this shaded area. What I can do is go to my z-table, look up 2 standard deviations. How to do that? Go to 2.0 where it matches up with 0, 0. This is the cumulative area from the start to 2. And 1 standard deviation, 1.0 where it matches with 0, 0. This is the area from the start to this point. When I take the difference of these, I will get simply the area in between. Okay, you can also do this with minitab, of course. As I've shown. Well, here, I'll just show it quick. Probability distribution, normal. Actually, let me just do both of them at the same time. Okay, let's say I want two standard deviations and 1 standard deviation. I'll do the probability distribution of the normal, cumulative probability, and here I want, in column 6, I want the cumulative probability of 2 standard deviations, the cumulative probability of 1 standard deviation. Here are both of the areas. If I take the difference of those two, I will find the area in between. Okay, if a value, so what is the probability of z being greater than negative 1.96? Okay, so here's negative 1.96. I know 0 is in the middle, so negative must be on the left side of 0. So here I want this greater than area. What you can do, of course, is look up on your z-table, go to the row negative 1.9, and where it meets up with 0.06, you should find the value 0.0250. Let's just make sure that's true. Okay, so here's negative 0.19. Here is 0.06. Okay, so where this column meets that row is 0.0250. But we need to realize that the table only gives us cumulative areas. Just like minitab only gives you the less than or equal to sign, so does the z-score table. Okay, so when you draw it out like this, we realize, hopefully very quickly, that the area that we're being given is this area. This is the 2.5%. If we want greater than that, we will have to do 1 minus this area. Okay, again, minitab, similar to what I've shown earlier. Here, what is the probability of less than or equal to 1.96? Like we saw, similar to we saw in the table, we got 0.0 to just about 5 if you round. What about the area in between these two values, negative 2.15 and negative 0.75? My suggestion, of course, is to always draw the picture so you don't get confused about what's going on. Negative 2.15 in between negative 0.75. Let me just do this one in minitab. Negative 2.15, also negative 0.75. And I want the cumulative probabilities of both of those, and then I will take the difference. Here, this is in column 8. Okay, so here are the cumulative areas. When I take the difference of these two areas, I find the probability of being in between there is about 21%.